Hi everyone. Today we're going to be talking about how to figure out the displacement of an object, or how far it moves, by looking at a velocity time graph, or a VT graph. This is the story of Paco the squirrel, which we've told a few times by this point using displacement time graphs and velocity time graphs. And I want you to focus on the velocity time graph. If you were just given that graph, could you answer this question? How far did Paco get throughout his entire story? If you were given the displacement time graph above, you could pretty easily see that he started his journey at a position of 0 meters, and he ended his journey at a position of 0 meters as well. So you could say pretty easily that his final displacement was 0. He ended up where he started, so he didn't get anywhere technically. So that would be correct. Now, could you get that 0 meters by looking at the VT graph? It might not be quite as obvious, but there is a trick to this. And here's the trick. If you use the area underneath each section of this VT graph, it will add up to the total displacement of Paco the squirrel. So let's look at the area of each of these sections. The first one that I've highlighted in green is an area of 2 by 1. So that gives us a displacement in that section of 2 meters. Now, to check if this trick works, look back up to the first graph, and you'll see that in the first second of time, Paco did in fact travel a displacement of 2 meters. Let's skip the second section where he was standing still for a second. Let's go to the third section. Highlighting the area under that part of the graph, we get another 2 meters because it's a height of 2 and a width of 1. So 1 by 2 is 2. Now, looking back up the DT graph, we can see that that's the point where he reached 4 meters of displacement. So 2 plus 2 does in fact equal 4. So this seems to be working so far. So I'm going to keep going. I'm going to skip the next 0 section, and I'm going to look at the velocity time graph where there's a velocity below 0. I'm highlighting that in red because that was a part of Paco's journey where he was traveling backward instead of forward. So that kind of cancels out his progress a little bit. If he took some steps forward and then took a few steps backward, he's not going to end up farther. He's going to end up closer to his original destination. So this would account for negative 4 meters of displacement. And in fact, in the DT graph above, you can see he traveled backwards 4 meters. So that matches up. In the next significant section, you can see that he went forward 5 meters. On the DT graph, and on the VT graph, counting up 5 blocks means adding another 5 meters, so that still matches up. And the last section where he was actually moving was between seconds 8 and 9, where he was traveling backwards 5 meters. Well, here's 5 blocks that are below the axis, and so counting up that area, we get negative 5 meters, because there's an area of negative 5 times 1. So if we add up 2 and negative 4 and positive 5 and negative 5, that totals up to 0 meters. So this trick that we're going to use in this video and that you can use in class is a really easy way to take a graph like a VT graph, which does not show displacement directly, and you can figure out the displacement if you know this trick. So it's pretty handy. So what's the rule that we're going to use? It's that the area under a VT graph actually secretly tells you what the displacement of the object was during that period. And if you find the area under the VT graph for the whole graph, the whole journey, then you will be finding the final displacement of the object after everything has happened. So let's use that trick on another familiar tale, which was the story of Peanut the puppy. Now, I'm not going to retell the story, but you may recognize this graph from a previous video where he was running forward, then he ran backward, and then he ran forward again. And again, as a reminder, everything above the 0 axis on a velocity time graph means forward. Everything below the 0 axis on a velocity time graph means backward motion, and anything on the 0 line means at rest or not moving. So, how far did Peanut get by the end of his story? What was his final displacement? It's not going to be 0, it's going to be some other number. Let's use the trick that we just learned to figure out what his final displacement is. Let's find the area under this VT graph. Now, I say under, and I really mean in between the lines of the graph and the 0 axis. So let's figure out what shapes we should break this weird graph shape into, because it seems like it's a bunch of rectangles and triangles that if we broke it up. So let's remember that the area of a rectangle is base times height, and let's remember that the area of any triangle is 1/2 times base times height. So the first section between 0 and 2 seconds, I'm going to highlight that because that's a triangle shape. So I can use 1/2 times the base, which is 2, times the height, which is 3. 1/2 times 2 times 3 equals 3. So in that time period between 0 and 2 seconds, I just figured out that Peanut the puppy went forward 3 meters. Let's look at the next section, which is between 2 and 4 seconds. I can easily pick out a rectangle there. The area of a rectangle is base times height. So the base of that rectangle is 2, the height is 3, 2 times 3 is 6. So in that time period between 2 and 4 seconds, Peanut went forward 6 meters. Let's look at the next section. As he was slowing down in that little triangular section there, we can see that our area calculation is going to be 1/2 times 1, because that triangle has a width of 1. And then the height is 3. So 1/2 times 1 times 3 equals 1.5. So he traveled forward an extra 1.5 meters while he was slowing down to a stop. So now that he stopped, we can see that the graph is about to go below the 0 axis. So this is going to be the point where he is retreading his steps and going backwards and taking away some of the progress that we just made. So the first section, which is below the 0 line, which is why I'm putting it in red, because we're actually going backwards here, is a triangle. The base of that triangle is 1, and the height of that triangle is not 3, it's -3, because it's below 0. So it's not 3, it's -3. So the area turns out to be -1.5 meters. The next section is also below the 0 axis. It looks like a rectangle. So you could do base times height. The base is 1, and the height is -3. 1 times -3 is -3 meters. So he's retreading a lot of his ground here. He's already gone back 4.5 meters backwards. And the next section where he's going backwards is another triangle. So 1/2 times the base, which is 1, times the height, which is -3, gives us -1.5 meters. So now he's stopped once again, and the final part of his journey is where he's moving forward, kind of similar to at the beginning of his journey. So let's look at that triangle right there between 8 and 9 seconds. 1/2 times the base, which is 1, times the height, which is 3, is +1.5 meters. And the last section is a nice little rectangle there with a base of 1 and a height of 3. 1 times 3, of course, is 3 meters. So 3 plus 6 plus 1.5 minus 1.5 minus 3 minus 1.5 plus 1.5 plus 3 gives us an answer of 9 meters. So how far did Peanut get? What was his final displacement by the end of this journey? It was 9 meters. And that specifically is 9 meters forward as opposed to -9 meters, which would have meant backward. So is there some way that we could have guessed whether this number was going to be positive or negative or 0? Yes, the way you can guess whether something's going to end up in front of or behind where it began is the amount of area of this graph that's above the 0 axis. If there's more space, more green sections that are above 0 than there are red sections below 0, then you're going to end up with an object that has traveled forward by the end of its journey instead of backward. If there was more red than there was green, then this object would have eventually ended up behind where it started. So now that you've learned all kinds of tricks for how to use velocity time graphs and displacement time graphs, I want to summarize for you the 2 most important tricks that you've learned so far. If you're presented with a DT graph, which tells you where something is and how far it goes, you can use the slope of that DT graph at any point to figure out how much velocity the object has, its speed, how fast it's going. So that's a trick for turning DT graph information into VT graph information. Now, if instead you're presented with a VT graph and you need to figure out distance information, like how far something went, maybe its final displacement, then the trick with VT graphs that we just learned is to find the area under the curve of that VT graph, and the area under the curve will be equal to the final displacement of the object. So this is the 2 most common tricks you'll use when you're looking at motion graphs, and hopefully these are helpful to you in your physics journey. So I'll see you guys in the next video. Hope that was helpful.